as possible, is we are going to start the unit on evolution. Again, this is chapter 22. I know you've written this down. And chapter 22 is really all about the history that's behind evolution. And when I say history, I'm not saying the word proof, I'm really saying the history behind it. So this is like a little history lesson, if you will. And so that means that we're going to study a couple of unique individuals. And the first individual I want us to talk about is Carlos Linnaeus. And really, to study history, in this case, I'm just going to go through a series of scientists that are important in Darwinian evolution. And I'm starting kind of with the oldest case. This guy, Linnaeus, we've already mentioned it before, but I think it was really just mentioning him. This was the guy that developed taxonomy. And we know what taxonomy is, correct? What is that? Right, a system of naming stuff. That's a naming system. Now, why is it important to name and classify stuff? Well, it's quite simple. I mean, just keep it straight, right? I mean, keep it simple to understand. And maybe even to show relations between creatures, and that's what Darwin used with taxonomy. And initially, this was first used with botany, which of course is the study of plants. The reason that that would be valuable, and that's what Linnaeus studied with taxonomy, was like a botany situation with it, is because back in those days it was plants were the cure for all things. The medicine wasn't in a vial, it was growing in the ground, basically. And then moving forward, away from taxonomy and Linnaeus, I want to talk first or secondly about Georges Cuvier. And what Cuvier did was he was a guy that studied paleontology. And what is paleontology? Bones, right? Fossil guy. Now, pretty logical question. You even saw one of these questions on your semester exam, if you remember. What would happen as I dig deeper in the ground? Would I find fossils of something that's older or more recent as I go deeper in the ground? Older. So the deeper I go, then the more unique the creature should be. The more anti-today, or the anti-today or opposite of today they should be, right? Well, of course, like digging deep into the ground in a quest for fossils, I think would really show you a lot about the way this planet has changed. And what Cuvier had decided was he decided that as he went down deeper and deeper into the fossil layers, or different stratas we call it, he saw that creatures changed very quickly over the course of time. In other words, he dug and dug and dug and everything was the same, and all of a sudden you're like, where are all those creatures at? And now there's something totally new. And what he decided was that this planet and the biology of this planet was really based on the existence of massive global events. This idea that catastrophes predicated what biology was around. So in his ideas, global change caused massive biological shifts. And I think that makes sense. You know, the outlook on things, the biology that would exist, would change if this planet changed. I mean, let's face it, if an asteroid hits this planet, things will go away. Because an asteroid has made them go away. That's what we believe happened to the dinosaurs, so Cuvier's idea is not too far-fetched. Cool. And then I want to talk about a couple of other guys, and two that I want to talk about at the same time is James Hutton. And I also want to talk about Charles Lyell. And what they had described, and it's not they were really collaborating, it's just their things kind of seemingly are about the same. They both believed that there were uniform changes that could be seen on this planet. They saw that there was a, if you will, like a uniform or a constant rate of change. And there really is a constant rate of change, except when we have these major events. So, I mean, if you really think about it, you've got something that's in direct opposition to these two guys with Georges Cuvier. So again, these two are directly opposing each other. Okay, so we'll move on, and let's talk about Lamarck on this next one. Kind of our next scientist that I want to discuss. Let me put a little C in there real quick. And Lamarck's idea, his idea of a changing Earth was all about use and disuse. His is kind of my favorite because it's the one that makes the least sense of them all. In Lamarck's idea, a baby inherits whatever his parents or her parents has done. For instance, if I decided to no longer go to Cece's, which is an amazing place to eat food if you've never been, and if I decided that I was going to go to the gym, work out, eat, you know, salads and soups and all that kind of stuff, and only that, and I get all swole up, you know, you don't know what that means, right? I get buff. Then Lamarck's idea would be that if I do that, that my baby's going to come out and be just as strong as me. Or not my baby, our child, whenever our child is birthed, in 20 years or so, will come out as strong as I am. So if I can bench press 400 pounds at that time, then my little boy can bench press 400 when he comes out, and then possibly he could be benching 800 by the time he's my age. Well, by that time, if you think about that, then we'd all be Superman by now, and we're obviously not all Superman. So the difference here has really got to be this idea. No, actually, Lamarck's idea doesn't make sense at all. It's completely unfounded. Your book uses an example about the giraffe neck. So I want to write that down. Basically, in Lamarck's concept, and this is kind of the example he used in his publications, I believe, he said that giraffes' necks are as long as they are because they're progressively trying to reach higher and higher foods. Does that make sense? So, like, that's why their necks are so long. That'd be like saying that, like, you stretch your arms like this each day, and the next thing you know, by the time you're 80, your arms are the length of a classroom. Like, that's impossible. In fact, your arms probably shrink down by the time you're 80 years old. They certainly haven't grown that excessive size. I mean, his idea just doesn't make any sense. And then, the next guy we've got.
Do you think he was really smart?
Did I think he was smart? Not as smart as me.
Lamarck think he was smart.
Everyone thinks they're intelligent. Just some people aren't. You know? Campbell and Reese thought they were. And they are.